welcome, Rabia. I'll hand over the floor to you.
Okay. First of all, I have prepared a presentation in graph theory. Can you please allow me to share my screen?
Of course. Let me make
Okay.
you a co-host. Okay. Okay, please try now.
Okay. Let me just give me 2 minutes, kindly.
Absolutely. Go ahead.
Okay.
While Rabia is setting up, I wanted to share with you guys the upcoming schedule. We have a presentation on Monday in regards to reflective practice. It's in the area of psychology by Rabia Liaquat. On Tuesday, we have a presentation in human resources and leadership by Lana Stemanovic. On Wednesday, we have Monica Fonseca presenting molecular biology. On Thursday, we have Mark Alphonse presenting psychology and pharmacology. And Friday, we have Jay presenting to us database, web development, and artificial intelligence applications. So very interesting topics coming up. They're all scheduled for the same time, 10 a.m. So I'm happy to see some familiar faces, and I hope you keep coming back. Rabia, I see your screen now.
Okay.
If you want, if you're ready, please go ahead.
Let me introduce myself. First of all, I'm the student of PhD mathematics. I have been research in the topic of graph theory, which is the branch of mathematics, where we can see mathematics in the form of graphs. Okay. First of all, let me introduction. What is graph theory? Actually, what is graph theory? In the domain of mathematics and computer science, graph theory is the study of graphs that concerns with the relationship between among edges and vertices. We have two things here. One is edges and one thing is vertices. Then can you please confirm you are listening me or not?
Yes, perfect. I hear the sound perfectly
Okay.
clear.
Okay. Then we will make things in the form of graphs. Okay. We have two things. One thing is vertices, which is just like a dot. We have lots of dots, and we will connect through edges. Edges is something line between dots, etc. Okay. It is a popular subject having its application in computer science, information technologies, business, mathematics, and many other fields. Okay. Introduce the exact definition of a graph. A graph is a visual representation of a set of objects. Uh, Formally, a graph is a pair of sets VE, where V represents vertices and E represent edges. Connecting the pair of vertices, let me use an example. Here you can see a graph where A, B, C, D, and E. These are the vertices, and then line join A and B, A and C, C and D, and E. These are all edges. This is the set of edges. Any question?
So far, it's very clear, Rabia. Thank you very much.
Okay. Then I am going to towards application of graph theory in daily life. Okay. Graph theory has its application in diverse field of engineering, electrical engineering, computer science, networks, linguistics. all the platforms of where we can use graph theory. Okay. In electrical engineering, the concepts of graph theory, the concepts of is used extensively in designing circuits connection. Let we have it where we can connect nodes through edges. The type of organization of the types of or organization action are named as topologies. Some example for topologies are star, series, and parallel topologies. We can draw graph like stars, bridge, series. These are all we can understand through a graph. Then computer science graph theory is used for the study of algorithms. For example, Kruskal's algorithm, Prism, Prime's algorithm, and Dijkstra algorithms. We will discuss these examples next. I have make an example of Dijkstra. Okay. Next, computer science. The relationships among interconnected computers in the network follows the principle of graph theory. Then science, the molecular structure and chemical structure of a substance, the DNA structure of an organism, etc. represented by graph. Again, next, linguistics, the parsing tree of a language and grammar of a language uses graph. Now, let me introduce a new thing in graph theory. This is degree of vertex. The degree of a vertex is the number of edges connecting it. First of all, we have an example where you can see A, B, C, D, and E. These are vertices. And let me check how many edges from A. Anyone can tell me how many edges from A?
Two.
2. And how many edges passing through B?
Three.
3. Okay, good. So degree of vertex of A is 2. Degree of vertex of B is 3. Similarly, how many edges passing through C? 1. That means degree of vertex through C is 1. This is the main concept of degree of vertex in a graph. Next, pendant. If we have an edge which is only one edge, that's called pendant vertex. And if there is no edge passing through an vertex, which is called isolated vertex, that's called E. E is an isolated vertex. Now we will move towards types of graphs. Okay, types of graphs. First of all, we have only vertices and no edge, called null graph. There is no relationship between any vertex. Next is graph. A trivial graph with only one vertex is called a trivial graph. If in this example, A, B, and C, if we remove B, then we have only one vertex that is called A, and which is called trivial vertex. Understand?
Yes, Rabia, very clear.
Okay. Next, I will move another type of graph, which is cycle graph, and can be represented as Cn. If the degree of each vertex in the graph is 2, then it is called a cycle graph. Okay. And here is an example A, B, C. Next is P, Q, S, R, and then it will join towards P. In other words, if ending and starting point of a graph is same, then it will make a cycle graph. For example, A, B, C, and then it will move towards A. It is a cycle graph. If and in other words, if every vertex have degree sequence 2, then it is called a cycle graph. As we make the concept degree of vertex in above. Now I will move towards undirected graph and directed graph. The undirected graph is a graph where the set of nodes are connected together in which all the edges are bidirectional. Sometimes this type of graph is known as the undirected graph, where we
So
cannot
I so
what? Any question?
Was talking on the but it's muted. You can
Yes, go ahead. There was just an issue with someone's mic. They already muted themselves. One thing, is it possible to zoom in a little bit more on the slides? I can see right now about 3 of the slides. Is it possible to zoom in a little bit more on the one that you're discussing? Yes. Okay.
Okay.
Okay,
Yes.
that's good.
Okay. Undetected graph where we cannot see where the edge go towards. In other words, we cannot see the direction of the graph. This is an undirected graph and this is a directed graph where we can see arrows. This is a directed graph and this is an directed graph. Okay. Next is simple graph, a graph that is undirected and does not have any loop or edges. Multiple edges means if a if there is an edge between A and C, then this edge will be unique, not two from A to C. This is the concept of multiple edges, where there is no two edges move from the same vertices, like A and C. There is only one edge. That means there is no multiple edge and loops. Loops means an edge from vertex to vertex. There is no any edge which is come from A and end from A and to A. So simple graph is a graph where there is no any loop and multiple edges.
Rabia,
Okay, next. Yes, please.
just a concern. Can you please slow down?
Okay.
Okay, thank you.
Simple graph, a graph that is undirected. First of all, it has a property undirected and then does not have any loop. Loop means there is no any edge, there is no any edge itself to vertex. Suppose A is a vertex, there will be no any edge which is go towards vertex A. Okay. Then or multiple edges. Next is the example of multigraph, a graph with multiple edges between the same set of vertices. It has loop formed. This is a graph where multiple edges and loops are formed. Anyone can see there. And this is a simple graph where no multiple edges and no and loop. Connected graph, a graph where any two vertices are connected. Okay. If I can see this example, anyone can see.
yes.
Okay. If we can see this graph where A, B, C, D, and E, these are the vertices. Okay. If I will remove an edge between D and E, if I will remove an edge between D and E, listen carefully. If I remove an edge between D and E, then there will be two graphs here. And this is called disconnected graph. Understand or not?
yeah, understood.
Okay. If there is any issue, kindly tell me. Ask me.
Yes, Rabia, I had one question. I think this might be in a later part of your presentation, but if not, um, if you can share with us maybe when we would use a connected graph, maybe if it would be like in human populations or COVID infections, or like when these
Mm,
graphs would be used
mm.
by someone working in different industries or different fields or
Okay.
different governments. Okay.
Okay. Okay, sure. And now everyone knows about the coronavirus. Okay, if we consider people as the nodes, if we consider people as the vertices, if one vertex moves, if there is a connection between two people through coronavirus, then we will take an edge like coronavirus, and when they meet, and the both will be infected, and this is the main. This is the connected graph. We can make a connected graph. If Okay, another example, if we make a set of if we make a set of countries, if we make a set of countries, and we will connect from one country to an other country through an export some material or import some material, then we can make graphs. If there is a lots of material and we cannot explain in words, then we will make a graph, and we can visualize everything very clearly. Another example, I have an example in the last, where you can see very clearly the uses of graph 3 in real life. I have two examples, two examples, so we can discuss it later. Okay, connected graph, a graph where any two vertices are connected by a path. Okay, this is a connected graph. If we remove an edge between D and E vertex, then we can see two graphs here, and this is called connected graph. Next is planar graph. A graph G is said to be planar if it can be drawn on a plane or a sphere, so that no two edges cross each other to at a non-vertex point. Okay, if we have any cross between two edges, then it is called non-planar graph. First of all, we can see in this example, uh, edge AC and edge BE. These are close to each other. So this is called non-planar graph. And here, no two edge cross to each other. This is called planar graph. Any
Okay.
question?
Okay.
No, so far.
Okay.
So yes, please.
Next,
There's a question. Sorry. So what's the
G.
difference between
Hmm.
non-planar graph and the planar graph? What's the difference?
Can you please ask me again?
Okay, so I want to know the difference between the non-planar and the planar. Is it because I just see some lines that are just crossed like a curve?
Yeah.
I
Okay.
can't really figure it out.
Okay.
I don't
If
know.
any two edges cross each other, like here, A and C, this is an edge, and here B and E, this is also an edge, and they intersect to each other. This
Okay,
is
no vertex. No
this is
vertex.
non-planar graph, and here
Okay.
we can move our edge from A to C, and there is nothing intersection of any two edge. This is
Yes,
planar
yes,
graph.
yes, yes.
Okay.
What about if it was three-dimensional?
If we going to three-dimensional, then
Yeah.
this is in two-dimensional. When I can give you an example in three-dimensional, like a bridge,
Ah, very interesting.
a straight free bridge.
Very interesting. Thank you,
Okay.
Rabia.
Okay. Yes.
Okay.
All right, thank you.
Hmm. Hmm. Uh, Next is complete graph, which is represented by Kn. When each pair of vertices are connected by an edge, then such graph is called a complete graph. If we cover every vertex, for example, K1 is just a simple vertex. When K2 there are two vertices and there is an edge between complete graph with the two vertices.
Okay.
Here is represented as K2 epsilon naught 1. Here 2 is represented by vertices and 1 is edge. Next, complete graph is a triangle. Okay, one vertex, there are three vertices and this is connected by edges which is also 3. It means every vertex can be connected to another vertex. For example, we have a four vertices and we can connect to one vertex with two vertex, one vertex with third vertex, one vertex with four vertex. Similarly, second vertex with one vertex, third vertex with first vertex, fourth vertex with first vertex. It means every vertex will be connected to another every vertex. Clear? Clear?
Yes.
Okay. Next, adjacent vertices. What is adjacent means? Two vertices are said to be adjacent if there is an edge or arc connected them. For example, we take this example. These two vertices are adjacent vertices because there is a connection between two vertices. Okay, there is a connection. If there is a connection between two vertices, then these are called adjacent vertices. If we take the example, this one, anyone can tell me A and are adjacent vertices or not?
Yes, they are.
And A and D are adjacent vertices or not?
They are not.
Yes, good. Similarly, the same concepts will be for the adjacent edges. Okay, adjacent edges are edges that share a common vertex. For example, AC is an edge. Similarly, AB are edge. There are two edges and both are shared a common vertex A. That means AC and AB are uh, adjacent edges. Now, take the same similar example. Anyone can be tell me CD and DB. Are these adjacent edges?
Yes.
Okay, good. And similarly, DE and AB. Are these adjacent edges?
Yes.
Yes. AB and DE.
No.
No, because they not share a common vertex. AB is another edge, DE is another edge. No vertex is common in both edges. That's why no adjacent edge. Next, the concept of loop and multiple edges. Same concept will be in simple graph I discussed earlier. Okay. Loop. A loop is an edge that connects a vertex to itself. Any edge that connects a vertex to itself is called a loop. There, for example, this one vertex share an edge with itself vertex. This is loop. And what is multiple edges? If a graph has more than one edge joining some pair of vertices, then these edges are called multiple edges. For example, this one. These two vertices share the same edge again. These are multiple edges. Understand? Anyone can differentiate between loop and multiple edges.
Yeah.
Can anyone tell me about difference between loop and multiple edges?
A loop is a vertex that goes out and returns to itself.
Yes, good.
And a multiple edges is a vertex with different edges or more than one.
Yes, good, good. Nice. Now we will make a theorem. This is an application of graph theory. Now your confusion will become easier to see after these examples, which are related in real life problems. So let me explain what is handshaking lemma. Okay, give me just 2 minutes.
Sure.
That's the question, please. Is the meeting being
Yes.
recorded?
Yes. Yes.
All right.
Anyone participating, we should have an archive. So if you want to reference something that was covered today in the future, you'll be able to do that. I believe we will also have a transcript. So let's say that there's a particular topic that you remember that you wanted to check on, and you don't have to listen to the whole thing. You can actually search the transcript and find out exactly at what time that word was said, and then you can more quickly locate it. So we should have both a transcript and a video archive. And when Rabia comes back, I see Danielle, you have your hand up. Everyone can see that. You can also do the same. You go to the smiley face reactions and you can raise your hand if you have a question or want to add something to the discussion.
Sorry, just a follow-up question. I missed yesterday's meeting about biomass. Will I also have access to that going forward?
Yes, absolutely. We're getting this kind of lined up, and we should get the earlier classes archived and sent to your student section in the virtual campus. We're going to add them to the Merlin Media Center so that everyone can locate them. And so, yeah, we do plan to send you out the invitation for the new upcoming meetings, lectures, classes, and also sending you the links to the previous ones in case there's some that you missed and would like to listen to. So yeah, just give us a few more days and we should start doing that a few days after each conference, or maybe sooner. We'll see.
Hello.
Hi, Rabia. Yes, go ahead.
Okay. Let we discuss about handshaking lemma. In graph theory, handshaking lemma states sum of degree of all vertices is twice the number of edges contained in it. Okay. Sum of degree of sequence of all vertices. Okay. We make the concept clear. So, degree of sequence of vertices. Can anyone can please in the degree of sequence of edge C shown in the screen? Anyone can please tell me the degree sequence of vertex C? Yes, please, Umar.
Yes.
What is the degree of sequence of vertex C?
Mm, not English, is Spanish.
Spanish.
Well, the only way we can do the Spanish will be once we have it archived and we're going to provide a transcript. So we're able to transcribe every, the audio. And so we should be able to do a Google Translate of the entire presentation. But next week, we have, I think, 2 or 3 meetings planned in Spanish. So I hope you can join us for that. And if not, also join us for the English ones and learn a little bit and practice your English as well. So anyways, please go ahead, Rabia.
Okay, I asked the question, how many degree sequence, what is the degree sequence of vertex C? So there are 2 degree sequence of vertex C because there are 2 edges passing through vertex C. So handshaking lemma is tell us sum of degree of sequence of all vertices. This is there is missing degree of sequence. Can anyone please write here degree of sequence? Here we can write degree of sequence of all vertices. Sum of degree of sequence of vertices is twice the number of edges contained in it. For example, we have an example. This one, A have 2 degree sequence, B vertex has 2 degree sequence, C has 2 degree sequence, D has 2 degree sequence. Sorry, D has 1, 2, 3 degree of sequence, and E has only 1 degree of sequence. So we will add all these degree sequence. For example, 2 plus 2 4 plus 2 6 plus 3 9 and plus 1 10. So the left hand side of this one sum of degree of sequence of all vertices. This clear?
Yes, very clear. That's the sum
Yes.
of all the
Okay.
degree
Degree sequence
in
of vertices.
and
Every vertex.
and Acacio, Acacio Edu, you have your hand up. Please unmute yourself and ask if you have a question or a comment, please. Acacio Edu. Okay, let's go to Danielle. Noel, you have a question, please, or a comment?
Yes, good afternoon.
Good afternoon,
Good
Danielle.
afternoon.
Yes, it's not really a question that way, but I have to worry. First of all, The way you are writing, you cannot read very well. The handwriting is so small and the screen is partially occupied. It's not really spread everywhere in the screen. You cannot see very well the
Yes,
handwriting.
we can zoom out a little bit. I think
Yes, zoom in.
due to a technical issue, I think Rabia has managed to somehow present on her cell phone. So that's why
Right.
the screen is a little bit narrow. But I think right now it's good to zoom into the formula, but also Rabia, maybe you can zoom out a little bit so Danielle can see the full
All right.
formula. There, perfect.
Okay.
Yeah, there
Now I can
we can
see a
see.
bit well. Another worry is my name is not well spelled. It's E at the end and not E. The first name,
Okay.
then me is E
Yeah,
and not C. Yesterday, I'm asking it to be rectified. So
sorry. Sorry, yeah, I can't change that. I think that's when you register for the session, possibly. But
it
yeah,
was written like that yesterday also. So please, for the next session, I prefer they should be rectified so they can be me.
okay. Yeah, I'm not sure how I can change that.
Then my worry is now that let her present in such way they can understand. She explains well, but with example as she's doing, we can appropriately understand very well the issue because mathematics is not a language of everyone.
That's right.
Let
Yes,
her
it's a different.
after
Yes,
each, yes, after each presentation, she must bring out an application for us to understand very well as she is
yes.
doing. Yes, please, that's my worry. Thank you
Thank you,
very much.
Danielle.
You're welcome.
Rabia, go ahead. Thank you.
Okay. Here we see the left hand side, the sum of degree of sequence of all vertices, which is equals to twice the number of edges. Twice the number of edges. Now we will see how many edges. A to C is one edge, A to B is second edge, B to D is third edge, C to D is fourth edge, and D to E five edges. There are five edges, and we will multiply with C to multiply number of edges, which is equals to 10. Similarly, we can see degree sum of degree of sequence are 10. So 10 equals to 10. This is actually what the handshaking lemma says. If we can sum the degree of sequence of all vertices, that equals to the twice the number of edges. So the following conclusions may be drawn from the handshaking theorem. The sum of degree of all the vertices is always even. Okay, this is the result. Actually, handshaking lemma conclude that the sum of degree of all vertices will be always equals to even. The sum of degree of all vertices with odd degree is always even. Okay, odd degree means if there is three edges, vertex D has three edges, so this is odd degree of sequence. Okay, the number of vertices with odd degree are always even. The number of vertices with odd degree are always even. Okay, these are the three results which conclude by handshaking lemma. Now we will see another example, a graph theory. Let me. A graph that has 35 edges, 4 vertices of 5 degree 5, 5 vertices of degree 4, and 4 vertices of degree 3. Now we will find out the number of vertices with the degree 2 in this graph. Suppose we have a graph where we have total 35 edges and 4 vertices with degree sequence 5, 5 vertices with degree sequence 4, and 4 vertices with degree sequence 3. And we want to calculate required. What is required thing? We want to calculate the degree the vertices whose degrees are 2. We will solve this by using handshaking lemma, handshaking theorem. First of all, we will see how many number of edges. Example 1, first line, first thing is our graph has 35 edges. So solution, number of edges is equals to 35. And then 4 vertices of 5 degree. If we have 4 vertices with degree sequence 5, then we will multiply 4 with 4 multiply 5. Number of degree sequence of vertices is equals to 4. Number of degrees with 4 vertices is equals to 5. And number of degree 3 vertices is equals to 4. All these are given in example. Now we will assume the number of degree 2 vertices which is unknown. Let's say this is n. In mathematics, anything which is unknown, we we give him give a name like x, like n. So now we'll assume the number of degree 2 vertices is equals to, let we say, n small. With the help of handshaking theorem, we have the following thing. Sum of degree of all vertices is equals to 2 multiply number of edges. Clear? Just
Yes, very clear. I just wanted to mention we
Clear.
have about maybe 10, maybe we have about maybe 12, 13 minutes left. I don't know
okay.
how much of the presentation we still have. We have a
Okay.
couple of, I think one question, but I want to let you present if you have more examples to get through, just letting you know about the time.
Okay. So here we use handshaking lemma. Simple, put the values and calculate n is equals to 9. So we have 9 vertices with degree sequence 2. Next, problem 2. There are 25 telephones in Pakistan. Is it possible to connect them with wires so that each telephone is connected exactly 7 others? So real life problem. So let us suppose that such an arrangement is possible. First, we consider this arrangement is possible. This can be viewed as a graph in which telephones are representing using vertices and wires using the edges. Everyone is very clear about what is vertex, what is edge, and how we can connect them. So now we have 25 vertices in this graph. The degree of each vertex in the graph is 7. Now we will again use handshaking lemma. We know some degree of all vertices is equals to 2 multiply number of edges. So number of edges is equals to sum of degree. We want the number of edges. Required is something number of edges. So to here multiply, it will go another side and will divide with the sum of degree of all vertices. Simple, putting values and calculate the answer. But here it is 7.5. In graph theory, we not happy with the integers. We want exactly the number. So here you can see 87.5. This is an integer. That is a problem. So handshaking lemma. So handshaking lemma is not applicable on this one. Okay, next.
One quick thing. Do we have time for a question, Rabia? How are we doing with the presentation? Do you think you have time for a question, or do you want to cover the material?
Okay, sure.
Okay, so Acacio, Edu, did you have a question? Or I also saw, I think, Mohammed Edris. Thank you, Mohammed. If you can also turn on your camera, if possible, that would be great. If not, that's fine. Please ask. We can hear you. Go ahead.
It's Francis.
Oh, Francis. Okay.
Are you going to have copies of this? Yes.
Yes.
Are we going to have copies of this presentation since?
Yes. Yes, we will. Thank you, Francis, for asking. Yes, we should be having those ready in a few days and send them over to you. Mohammed Edris, I see your hand up. Did you want to ask something? Okay, so Rabia, one question I had was, um, it, these formulas, would you maybe use them like in a factory if you have multiple lines creating a product and you're trying to figure out logistics of bringing in multiple components from different parts of the factory, and like, would that be another application of the handshaking lemma to try to figure out efficiencies in production? Or
Yes, obviously we can use handshaking lemma in factory areas. If, for example, we have a product of chemicals, and we want a connection between them. For example, we have two chemicals. One is used in 10 milligram, and second one is 20 milligram. Then we can calculate and make calculations between them, and obviously we can use handshaking lemma between them.
okay, excellent. Well, I think Elvis, that might be good for you in your industry of energy, this handshaking lemma formula. And I think it also, Rabia, would be applied to simpler things like a supermarket, like the layout of a supermarket and the flow of the products and the human traffic for optimal efficiency as well. Or what are some other common applications that you can share with us? Maybe because of
Okay,
our
common
students.
application.
Yeah.
I can share you the common application, like in the last I was tell about the Gestra algorithm. This is the algorithm where we can find out a path which is shortest path. Okay,
Oh, fantastic.
these are
Very interesting.
algorithm. Yes, we for example, we have 2 points A and B, and there are many lots of paths, lots of routes to go from A to B, but we will find the shortest path. What is the shortest path? Like Google Maps will connect to 2 points, and they tell us the shortest path. These are all applications of graph theory.
Fantastic. Emmanuel Owure, do you want to add something?
Yes. So yeah. So we can see here the formula examples given. I think we can find it out. We can figure our way out of to solving that problem. But for me, the real issue here is the fundamental. So how do I know the number of edges and the number of degree? I think if I can just get that, then I can go through the rest myself.
Yeah, I think it would probably be through observation of the real life or probabilities. Rabia, what do you think?
Yes, I think when you are entering this field of graph theory, you will work with markets, and then you have a lots of data. You have a lots of data they provide you. You just need to pick the data and analyze what are these, how we can solve these problems. Everything which are in mathematics have data, lots of data. So through data we can solve all kind of problems.
So, Emmanuel, in your case, is there something particular that you're thinking about of maybe using this? Is there something that you were thinking, well, okay, I understand the theory. How could you apply it to you? Is there something in particular, a particular scenario that you want to contemplate this implementing or utilizing these theories?
Okay, so when we have a chain of activity and there are so many data, so I think this can help you to kind of do a quick calculation of maybe what is the end product without really knowing the specific real value, but at least to give you an estimate by just running through the lines, and you know the angle, and you can just come up, okay, this is what I'm expecting, and the real value should be close to that.
Excellent. Thank
Yeah.
you. And I see a hand up by Mohammed. Edris. Okay, go ahead, Rabia. Thank you. Please continue.
Okay. Next, the concept is tree. A connected acyclic graph is called a cyclic. Acyclic graph means which are not cycle graph. Okay. So acyclic means which are those graph which are not cycle, means whose starting and end points are not same, or any vertex has no degree sequence 2. Okay, that graph is called tree. In other words, a connected graph with no cycles is called tree. The edges of a tree are known as branches. Okay, every tree graph has edges, so these edges are called branches. Elements of trees are called their nodes. The nodes without child nodes are called leaf nodes. Okay, a tree with n vertices has n minus 1 edges. Any tree with n vertices, for example, we have a tree with 5 vertices, then the edges will be 5. In general, here mention is in general, a tree with n vertices has n minus 1 edges. So let me take a example of methane. There are 1 2 3 4 5 vertices, but we have 4 edges. So there is a formula to calculate the edges. Any tree with n vertices has n minus 1 edges. So if it has on one more edge extra than n minus 1, then the extra edge should obviously has to pair up with 2 vertices, which leads to form a cycle. Then if we have any extra edge, for example, this is an graph with 5 vertices. If we draw any edge between 2 vertices, any 2 vertices, then it will make a graph, make a cycle graph. So we want a tree graph. That's why we have n minus 1 edges, not n edges. Okay. Becomes a cycle. Okay. Next is forest. A disconnected acyclic graph is called a forest. If we have 2 trees, even a one tree, if we have a tree and we will remove any edge between them, then we have 2 disconnected trees, and these trees are called forest. Like in real life, we have a forest and lots of trees in a forest. Similarly, you can make a concept in your minds. Where huh. A disconnected acyclic graph is called a forest. In other words, a disjoint collection of trees is called forest. And this is a graph. You can see there are 2 trees. Next is spanning trees. Let G be a connected graph. Then the subgraph H of G is called a spanning tree of G if H is a tree. H contains all vertices of G. Okay, spanning tree. What is spanning tree? Let's suppose we have a graph G. We have a graph G, and we will make a graph from G. Make a graph from G means subgraph of G. See, there is a graph G, and we will remove edges AD and CF. Remove the edges. Now H is a graph which is born from G. So now we will check the properties of H. First of all, H should be tree, and every vertex H contain all and H contains every vertex of G. C, A, B, C, D, F, G, E. Every vertex is present in H as well. So this will make a spanning tree. First of all, the concept is what is the concept of spanning tree? We have a one graph. Let's suppose this is G. We will make another graph which is a subgraph of graph G. Then we will check the properties, two properties of graph in H graph. First of all, H should be tree. Second one is every vertex contain H, which is also present in G. If these two properties satisfy, then the this is called spanning tree. Clear?
Yes.
Right.
Yeah.
Next one is Euler path. What is Euler path? Euler path contain each edge of G exactly once and each vertex of G at least once. Okay. First of all, we everyone very clear about vertices and edges. Now, what is Euler path? Euler path is the path in the graph where every edge should be come once. For example, if we move from this one graph, so A should be moved to B, B to D, D to E, E to D, D to C, C to A. Clear? मतलब every edge will be covered. If we move from uh, A to B, B to D, D to C, and C to A, exactly once edge. So this is Euler path. Now Euler circuit. What is Euler circuit? Circuit means cycle. Circuit means closed path. Okay. In an Euler path, if the starting vertex is same as its ending vertex, simple. What is cycle? Ending and starting point should be same. So Euler circuit, this is also the same. So what is the difference between Euler path and Euler circuit? Anyone can please tell me what is the bit yeah, in other word, what is the difference between path and circuits?
Anyone? I guess one is a closed circuit and the other one just goes through the points, but it doesn't repeat.
Yes, this exactly. Path is simple a path, not close, not go back. Simple a path, and circuit is a closed path. Clear?
Yes. Mohammed Edris, you had your hand raised. You were having some issue with your sound. Do you want to try now? Mohammed? No, unfortunately, we can't hear you. Go ahead, Rabia. We're already past the hour by 6 minutes. Do you want to try to wrap up the remaining topics in a couple of minutes, or?
Okay.
Okay, fantastic.
Okay, next Hamiltonian graph, same concept like Euler path, but the main difference is only edge and vertex. Here we can exactly once and each vertex. We will cover here every edge, and here we will cover every vertex. Okay. A connected graph is said to be Hamiltonian if there exists a cycle which contains all the vertices of G. Every cycle is a circuit, but the circuit may contain multiple cycles. Such a cycle is called a Hamiltonian cycle of G. Next, Hamiltonian path, a connected graph, is said to be Hamiltonian if it contains each vertex of G exactly once. Okay. For example, if we move from A, B, C, D, E. Every vertex is covered exactly once. Clear? Next, Euler circle contains each edge of graph exactly once in a Hamiltonian. Here is the difference between Hamiltonian path and Euler's path. Euler's circuit contains each edge of the graph exactly once, and in Hamiltonian graph, some edges of the graph can be skipped. Clear? Next, Dijkstra algorithm. Dijkstra algorithm allows us to find the shortest path between any two vertices of a graph. ठीक है? Right? This algorithm will find out the shortest path between any two vertices. This algorithm is used to find the shortest path in Google Maps, in networks routing protocols, in social network application, and also in many places. Right? These are the places where this algorithm, where the graph theory used in Google Maps, network routing protocols, social networking applications, and many places. For a given graph, Dijkstra algorithm is helpful to find the shortest path between a source node to a destination node. For example, if we draw a graph in which nodes represents the cities and weighted edges means every edge has some weight. For example, 2 millimeter, 10 millimeter. Means we will value the edges. We will give some value of edges. So if we draw a graph in which nodes represent cities and weighted edges represent the driving distances between pairs of cities connected by a direct road, then the Dijkstra algorithm, when applied, gives the shortest route between one city and all other cities. This algorithm is also used in GPS devices to find the shortest path between the current location and the destination. It has broad applications in industry, especially in domains that require modeling networks. Right?
Yes.
Okay. Now this is an example. For example, vertices shows cities, vertices shows countries, anything, and these are the paths to go from one country to another country, one city to another city. So first of all, we have nodes or vertices 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want to move from 1 to 9, and we will find the shortest path between 1 and 9 by using the Dijkstra algorithm. Okay, first we have two ways to move from 1 to 2. One weight is 2, and second hmm, only one path from 1 to 2, that is 2. Next we want to move from 2 to 3 and 5 because these are adjacent to 2. Again we want move from 1 to 9. First of all, we want to move 1 to 9, and we have to move 1 to 9 three adjacent vertices with 1. First adjacent vertex with 1 is 2, second one is 3, and third one is 4. Okay, then we will make the shortest length, which is 2. Okay, which is 2. Now we will see that from 1 to 2 is 2, from 1 to 4 is 2. Right? So first of all, I will choose 1 to 2. For example, I will choose 1 to 2. So there is weight 2. Now we will move from 2. There are adjacent vertices next to 2 is 5 and 3. Either we will move towards 5, either we will move towards 3. So we will choose the shortest length, which is 1, which is from 2 to 5. Okay, next we reach at point 5. Now we will move towards 9, and we have adjacent vertices 3, 8, 9. If we move from 9, from 5 to 9, there is a heavy weight, there is a heavy distance which is 7. So we will move towards 3, which is distance only 1. So we approach to 3. Now we will move towards 6 or 8. The shortest length will be 1, and then we'll go towards 9. Here you can try every path. You can try every path, and then the shortest path will be digester algorithm. Since 1 2 5 9, 1 to 2, a person move from 1 to 2, then from 2 to 5, from 2 to 9. This is first one. Then when we add the lengths, this is 10. Second method was 1 to 2, 2 to 3, 3 to 8, 8 to 9. And we will sum the all lengths, which is 6. Next we can also move from 1 to 3, 3 to 8, 8 to 9, which is 7. And 1 to 4, 4 to 7, 7 to 6, 6 to 8, 8 to 9, and sum of all lengths is equals to 10. So the shortest path is 6. Clear?
Yes, very
Yes.
clear.
Yes. Okay, good. So we will calculate every path, and the that one which is shortest is digester algorithm. Now we will see the applications and drawbacks, disadvantages of digester algorithm. To find the shortest path between source and destination, which is the application of digester algorithm. Next, in social media applications, to map the connections and informations, in networking, to route the data to find the location on the map. Very clear applications we use in daily life, our daily life. So disadvantages, it follows the blind search, so waste lots of time to give the desired output. Clear? This is the advantage. Since if we want to move from 1 to 9, but we have no very clear from where we can go, from 1 to 2, from 1 to 4 to 3. So this is the disadvantage of the this algorithm. It negative edges value cannot be handled by it. If we the edges have negative value, then we cannot handle this in digester algorithm. We need to keep track of vertices that have been visited. We should track the vertices from where we want to visit.
Perfect. Thank you very
So
much,
these
Rabia.
are the welcome.
Yeah, I thank you so much for this presentation. I see there the red lines are the fastest path, the shortest
Yes,
path.
yes,
And
yes.
Emmanuel, you had your hand raised. That'll be the last question for the day. Please.
Yes. All right,
go
thank
ahead.
you. So let me go quickly. Yeah, so I see the alien circuit that shows that it's a closed path, so that is clear. But for the alien path, I can see that at one end we have a circuit, then at the other end we have a path that is open. So is it that as long as there is an open path attached to the flow, then it is not a circuit at all? Because I see that if you go to the left, they will have a circuit before we have the E path. That makes it a path. So I think it's a combination, but why is it now a path and not a circuit and path? I don't know if you can scroll up a little bit, maybe using the diagram, you will see.
Rabia, did you get the question from Emmanuel?
No, I did not get. What is the question in simple words?
Okay, fine. Let me go slowly. I'm talking about the alien path that you explained earlier.
Path.
So
Okay, so go up a little bit, I think, in the
yeah, go up a
presentation.
little bit. Yeah. So for the
This
circuit,
one.
that is fine because it's a closed path. Yes, yes. So
Yes.
I see the path DE that is open. Okay, that makes it a path. But if you look at the other side of it, we have a circuit. So is it because we have the DE aspect, that's why not considering the ABCD, then it is a path, because the ABCD is also a circuit.
Okay. First of all, in Euler circuit, we want to cover every edge, right? In Euler circuit, we want every edge cover exactly once. So that's why we want to go with G, F, E. So A to B, B to C, B to C, sorry, A to B, B to C, C to D, then D to C. And then, sorry, A to B, B to C, C to D, D to A, then go with G, then F,
To E.
then C,
Yeah.
then A. So every edge should be covered at least one.
Yeah, okay.
So that's
It's
why
clear. So
that
which means you go from D to C, C to A to B, B to D, then D to E. Then becomes an open path. Okay, it's clear. It's clear. Thank you.
yes.
And I know, guys, today we had a little bit of a technical issue, and Rabia did a really great job of presenting on her mobile phone. If it's possible, Rabia, I don't know if you can, just to say goodbye, to turn on your camera for a moment, so we can greet you,
Yes, yes,
if
of
you
course.
can. And I just want to, I'm very happy to see so many participants today and repeat participants. I see you were able to change your name already. I see that. I see your name different now. Good.
Rabia Liaquat.
But anyways, I hope maybe Rabia can turn on her camera so we can meet her. And Rabia, I think some of these topics, I think there could be a whole presentation on each one of these theories, and
Yeah.
you know, with maybe pictures of or videos or real life cases where we look at, you know, hey, this was implemented in COVID-19. This was implemented in a supermarket. This was implemented in a traffic stop. That would be so interesting. So I hope we can have you back in the future when you're available. And
Yes, yes, of course.
anyways, well, I don't think we're going to be able to see you today, but it was wonderful having you and listening to you and seeing your presentation. So
Thank you so much.
thank you, guys. Thank you, everyone, for joining us today. Have a wonderful weekend.
Okay.
Well,
Yeah, thank you very much.
Thank
And you
Thank you very
too.
much.
Thank
everyone.
you.
Thank you so much.
Thank you so much.
Thank you so much.
Thank
Thank
you.
you so much.
Thank you, everyone.
Thank
Many
you.
thanks.
Thank you.
Thank you.
Ciao.
Bye.
Thank you,
Thank
Rabia.
you.
Appreciate it.
Thank you so much.
Lovely
Thank you.
weekend.
Okay, good.
Bye, everyone.
Thank you.
Bye.
Bye
Cheers.
bye.